Hello guys, welcome back to the third part of the video of trigonometric substitution discussion. But in this video, it is very different since I am introducing to you another or additional trigonometric rule that we will be using in our next example. We have here the integration, that is du over square root of u squared minus a squared. If you have this type of function, then your integration would be the natural logarithm of u plus square root of u squared minus a squared plus c. Now, if you have the integration of du over the square root of u squared plus a squared, that is the natural logarithm of u plus square root of u squared plus a squared. So the only difference here is that if we have positive, then we have negative here, but still our u is in the first term, then we can apply this function. Unlike in the inverse trigonometric function, our a squared is at the first term, correct? But in logarithmic form, our u squared is in the first term. If you remember the last video that I have introduced, or I introduced to you the trigonometric function. And then we have the integration of du over u squared minus 1 is equal to 1/2 natural logarithm of 1 minus u over 1 plus u plus c. And then if you have the integration of du over 1 minus u squared is equal to 1/2 the natural logarithm of 1 plus u over 1 minus u plus c. Again, our u here, that is the any function of x, okay? And our a here is the constant, okay? So you have to remember that you can use either of this rule or the conventional way, which is trigonometric substitution. But in this video, we will try to solve problem using either this integration rule and the trigonometric substitution procedure. Now, I have here an example. We have the integration of 2 dx over square root of x squared plus 2x plus 8. Now again, this can be used trigonometric substitution since we have fraction and then we have square root sign, or the radical sign in the denominator, that is x squared plus 2x plus 8. Now again, before we can apply trigonometric substitution, we need to determine first which is our u and our a. Okay, so let's identify first our u and our a. However, in our radicand here, we have quadratic equation, okay? We have x squared plus 2x plus 8. So we cannot identify which is u here and which is a since we have 3 terms. So in this case, we need to again apply completing the square, okay? How are we going to do completing the square? We just introduce a number so that we could apply completing the square, or we could create a square of binomial. So if our quadratic equation is x squared plus 2x plus 8, okay, so we know that if we have x squared plus 2x, then we could have another term here. So our term here is the, I have a technique on how to compute for the third term. That is just 2 divided by 2, that is give us 1. Then square of 1, that is equal to 1. So therefore, we add 1 here. Then do not forget that we still have 8. And then since we added 1, we should add another number that is opposite in sign. Okay? So since we add positive 1, then we add, or we introduce negative 1. Again, since 1 minus 1 is equal to 0, so since upon introducing 1 in our equation, our function or our equation has changed. Nagbago ang equation. So therefore, we need to come up with another number so that, or to balance the function. So therefore, our function has not changed when we introduce negative 1 here. Okay? So again, we introduce negative 1 so that we could balance the equation and the value of the equation will not change. So therefore, we can write this as the integration of 2 dx over, that is the square root of x squared plus 2x plus 1, then plus 8 minus 1. And we could simplify it further. We have the integration of 2 dx over the square root of, we know that x squared plus 2x plus 1 can be simplified as x plus 1 squared, correct? Since if we have x plus 1 squared, we can evaluate it as square the first term. Okay, we have x squared, multiply the first term and second term, we have x times 1, we have x, and then multiply it by 2, we have 2x, then square the last term, we have 1. Okay, so therefore we could say that it's x plus 1 squared, then 8 minus 1 here, this is 7. So therefore we have plus 7 here. So by checking this form, we could say that our u here is this one. This is our u squared, and this one is our a squared, correct? So therefore our u squared here is equal to x plus 1 squared, and our a squared here is equal to 7. So then we have our u here is x plus 1, and our a here is the square root of 7. Okay, so we have square root of 7. So we can rewrite this form into the integration of 2 dx over the square root of, we have x plus 1 squared plus square root of 7 squared. Okay, so this is our u that is being raised to 2, and this one is our a that is being raised to 2. Then we have come up with the integration rule, that is we have the integration of du over, now take note this one again, this is u, so we have square root of u squared, then this one again is our a, so we have plus a squared. So let's check in our integration rule. Let's choose whichever satisfies or whichever is similar to this function. And as what you can see here, the second rule, okay, satisfies our new function, that is du over the square root of u squared plus a squared is equal to the natural logarithm of u plus square root of u squared plus a squared plus c. So we can now use this one, and that is the natural logarithm of u plus square root of u squared plus a squared, we have plus c. So we have identified already which is our u and which is our a. Okay, however, we need, since we have du here, so we need to check our du if it satisfies our required du. Now our du, if we differentiate this, our du here, that is du is equal to dx. Okay, so upon checking at the function, we can actually take 2 out of the integration. So our du here, this one, that is du. So it has been satisfied already. However, if not, okay, so you introduce again a multiplier and the reciprocal outside. So the same as with the previous integration rule. So let's continue. We have this function here, that is the natural logarithm. Since we have satisfied our du, so we can directly use this one. However, don't forget we have 2 outside of the integration. That is, we have here 2. Then we use this form here, that is the natural logarithm of our u. Our u is x plus 1, correct? Plus, we have plus here. Then the square root of u squared plus a squared. Square root of u squared, our u squared is this one, x plus 1 squared. And our a squared here is equal to 7. So we have plus 7, then plus c. So therefore, this is now the integration of 2 dx over square root of x squared plus 2x plus 8. Now we use this integration rule that we had. Okay. However, what if we will be using trigonometric substitution to this problem? So if you try to make use TrigoSub, we have this form here, which is which was already simplified. So we will plot this in our right triangle. This is our theta. Now take note, now if this is our u, we have identified this our u, and this one is our a squared. Okay, that's u squared. Now we have to plot this in our right triangle, but since again we have positive in between u and a, therefore neither of these two is the hypotenuse. Now go back to the Pythagorean theorem. Now if you have CAB, so therefore that is our a here, that is square root of c squared minus b squared, or that is c here is equal to square root of a squared plus b squared, wherein our a and b is the side of our right triangle, and a and b here is the side. So therefore x plus 1 and 7, since we have plus sign here and we have plus sign, so therefore these are the side of our right triangle. Okay, unless if it is negative, we know that the first term is the hypotenuse. That's the one, that's the hypotenuse. Okay, if this is negative here, x plus 1 is the hypotenuse. But since it is positive, so therefore they are the adjacent or the opposite of theta. So we can plot this in our right triangle. We know that any function of x that should be as our opposite of theta. So we have here x plus 1, the opposite, and the adjacent. Now our a again, since a squared is 7, our a is square root of 7. Okay, so therefore this one here is the square root of 7. And then our hypotenuse here is equal to, that is x plus 1 squared plus 7, of course. Okay, that's the length of the hypotenuse. You just add the square of the adjacent and the opposite, then square root. So therefore, by looking at the right triangle, we can create a trigonometric identity. And in this case, if we have plus, we can apply tangent. So we have tangent of theta is equal to x plus 1 over, that's the opposite of theta, over the adjacent of theta, that's square root of 7. Okay, so therefore we can say that x plus 1 is equal to square root of 7 tangent of theta. Now derive, since we have derivative of x here, so we need to derive this one. That's the derivative of x is equal to square root of 7, that is the second squared theta, then derivative of theta. Now let's substitute everything in this formula. Then we have the integration of 2. Our dx is this one, that is square root of 7 second squared theta d theta, this is our dx, over, again we replace all the variable x in terms of theta or trigonometry. Then we have the x plus 1 squared here, that is equal to square root of 7 tangent theta, square root of, now x plus 1 squared, that is square root of 7 tangent theta squared, correct? Plus become p7. Okay, that's our a. So we have equals to, that is we have 2 square root of 7, that is second squared theta d theta, over we have square root of, now in this case square root of 7 we can distribute squared in this 2. We have square root of 7 squared, we have square root of 7 squared, the same as with 7 raised to 1/2 then squared, correct? When we multiply 2 and 1/2, that would give us 2 over 2, or that is 7. So therefore it would give us 7. Then tangent theta squared, then we have tangent squared theta plus 7. So we distribute squared in this term. So we can simplify it further. We have 2 square root of 7 second squared theta d theta, over, now we can factor out 7. We have 7, then that is tangent squared theta plus 1. Okay, we take out 7 in our quantity, then we could say that it is equal to integration of 2 square root of 7 secant squared theta d theta over, that is square root of 7 times, now we have tangent squared theta here from our trigonometric identity. Tangent squared theta plus 1 is equal to secant squared theta. Correct? That is equal to secant squared theta. And this will give us integration of 2 square root of 7 secant squared theta d theta over square root of 7 times, now if we get the root of secant squared theta, that would give us secant theta. Okay, so if we get the root of secant squared theta, the result would be secant theta, since we raised it into second degree. Then we can cancel out square root of 7 here, and also we can cancel out secant theta, and then the remaining secant theta in the numerator is 1. Okay, so we cancel out the secant theta, and the answer would be 2 secant theta d theta. Or we can take 2 outside of our integration, that would give us secant theta d theta, and we know that the integration of secant theta is equal to the integration of secant theta from my previous discussion on trigonometric integration. We have the natural logarithm of secant theta plus tangent theta plus c. Okay, so this should not be our final answer. Take note, our answer here is in terms of theta. So we need to replace this theta here by variable x, which is our original function. So how are we going to replace secant theta and tangent theta into function of x? Now let's go back to the right triangle. We have here secant theta. Again, our secant theta is basically just the opposite of cosine theta, or that is just the hypotenuse over the adjacent. Correct? So therefore, our hypotenuse here is this one, that is the square root of x plus 1 squared plus 7 over the adjacent square root of 7. So this is the value of our secant theta upon looking at the right triangle, this one here. Okay, so this is the hypotenuse over the adjacent, which is opposite of cosine. Now we have tangent theta in our function, but we have all determined already what is tangent theta, and from here we have known tangent theta is equal to x plus 1 over square root of 7. So we can now use this value in our answer. So we have here the answer from, that is 2, the natural logarithm, our secant theta, we have here, this is 1 square root of x plus 1 squared plus 7 over square root of 7, square root of x plus 1 squared plus 7 over the square root of 7 plus tangent theta, that is from the right triangle, we have x plus 1 over square root of 7 plus c. This should be our answer. However, from our previous solution, we have eliminated square root of 7 in our answer, correct? How did we get this one? Which in fact our answer using the trigonometric substitution is we have denominator of square root of 7, and we have to get the same answer as this one. So remember that you can actually combine these two, since we have the same square root of 7 as their denominator. So we have 2, the natural logarithm of, we can combine them since we have common denominator, square root of 7. That will give us, we write the first one, x plus 1 plus square root of x plus 1 squared plus 7 plus c. Okay? However, take note, we can factor out 1 over square root of 7 in this function. So we have 2 the natural logarithm of 1 over square root of 7. Then we have here x plus 1 plus square root of x plus 1 squared plus 7 plus c. However, we still have 1 over square root of 7. Now take note, if you remember the rule in logarithm, that if you have the logarithm of a, b is equal to the natural logarithm of a plus the natural logarithm of b, or if you have the natural logarithm of a over b is equal to the natural logarithm of a minus the natural logarithm of b. If you remember this rule from your trigonometry, so we can apply this one into this form. Now take note, we have 2 here. We set this as our a, and this one as our b, correct? So we can say we have 2 the natural logarithm of 1 over square root of 7 plus 2 the natural logarithm of x plus 1 plus square root of x plus 1 squared plus 7 plus c. Now why we have 2 here? Now take note, if we have 2 the natural logarithm of a, b, we can have 2 times the natural logarithm of a plus the natural logarithm of b. Then we can distribute 2 inside, that is 2 the natural logarithm of a plus 2 the natural logarithm of b. We can distribute 2 inside the parentheses. So the same as with this concept. Now take note, if we evaluate 2 the natural logarithm of 1 over square root of 7, the result would be constant. Okay, that's constant. However, take note, we have constant at the right side of the equation. So if we add 2 constant, the answer would be still a constant, correct? So we can we may not use a real number here, so we can set that as constant. Okay, so we have here the answer. Okay, let's eliminate this. Let's set that as constant. We have 2 the natural logarithm of x plus 1 plus square root of x plus 1 squared plus 7 absolute value plus c. And we have now the same answer with the integration using the logarithmic form, or the integration rule of logarithmic form. So we can say that this one is the integration of, that is 2 dx over the square root of x squared plus 2x plus 8. Okay, so again, you can use trigonometric substitution, or you can use directly this rule here. However, I would suggest you know how to use both ways, or how to use the conventional ways. You should have a backup plan in case you forget the integration rule. At least you know how to solve it using the conventional way. Now we have here the second example, that is the integration of 3 dx over the square root of x squared plus 12x plus 22. Now we might think again that this could be used, or this could be the integrate using the trigonometric substitution, by first letting us to determine our u and our a. Now again, our radicand here is in the forms of quadratic equation, so we need to apply completing the square to this one by again introducing a number. So if we have x squared plus 12x, so therefore you apply, or you introduce a number by getting or dividing 12 by 2, so you have 6, correct? Then square root of 6, that is 36, so you have here plus 36. Then don't forget that you still have 22. Then if you add 36, then you have here negative 36 to balance our equation. So you have here x plus 6 squared no? This one, you can compress this into x plus 6 squared, since again, if you evaluate this one, you could have this form. And then this one here, that is minus 14, okay? So we now use this one as a representation for this radicand. So we rewrite our integration, that is the integration of 3 dx over the square root of, we have x plus 6 squared minus 14. Okay, so upon looking at the radicand, we can directly conclude that this one is our u squared and this one is our a squared. So therefore, our u squared is equal to x plus 6 squared. Our a squared is equal to 14, correct? So therefore, our u is equal to x plus 6 and our a is equal to the square root of 14, since our 14 can't be does not have a exact root. So therefore, we can say that this one is our u squared and this one is our a squared. Now it is the same with the integration rule, that is the integration of du over square root of u squared minus a squared. So let's try to look at the list of the integration rule and let's find out in which rule can be applied to this type of function. And then we have the first rule, that is du over the square root of u squared minus a squared, that is the natural logarithm of u plus square root of u squared minus a squared plus c. So we have this one, the natural logarithm of u plus square root of u squared minus a squared plus c. However, let's try to identify du first. Our du here, that is only dx. So upon looking at the function, we can take 3 outside of the integration and we have satisfied du. So we may not introduce a multiplier and a reciprocal outside of the integration. So we are okay with this one. So we can go directly with this function. However, take note, we have 3 outside of the integration. So we copy 3. Then the natural logarithm of our u here is x plus 6 from this one. That is x plus 6 plus square root of, now u squared minus a squared is this one, correct? So we have x plus 6 squared minus 14 plus c. So this is now the answer, or the integration of 3 dx over x square root of x squared plus 12x plus 22. Okay, you can try using trigonometric substitution and the answer should be the same with this one. So I will leave that to you, okay? So you try to solve it in your own.